In this video, we will be looking at my favorite distribution, the binomial distribution. It's my favorite because it's super simple to use and there's a shortcut to finding the mean and the variance. First, we must establish the rules of a binomial distribution. The prefix bi means 2, and it's no coincidence that our binomial distribution only has 2 events that you can choose from. These events are often called successes and failures. Here, the only 2 options we can pick from is a red ball or a purple ball. If I were to pick randomly, the probability of picking a red ball would be 3/4, or 75%, and the probability of picking a purple ball would be 1/4, or 25%. Let's find the probability of picking a red ball, then a purple ball. This will be done with replacement. Remember what replacement is. It means after I make my first pick, I put that ball back into the box. In other words, my events are independent. Therefore, I can use the simplified multiplication rule. What if we had to find the probability of picking a red ball and a purple ball? Did you catch the difference in my phrasing? The previous question said, and then, which specifies an order, while this question just says and, which means an absence of order. This means that there are 2 ways this procedure can play out. Either I draw the red ball first and then the purple ball, or I can draw the purple ball first and then the red ball. Then the probability of picking a red ball and a purple ball is the sum of these 2 individual cases. What if we want to find the probability of drawing 2 purple balls and 1 red ball with replacement? Well, there are 3 different ways that we can achieve this. I can draw a red ball from my first trial, then 2 purple balls from my second and third trials. Or I can draw a purple ball on my first and third trial, and a red ball from my second trial. Or I can draw a purple ball from my first 2 trials, and a red ball from my third trial. Using the addition rule, I can compute the probabilities of each. And to find the probability of drawing 2 purple balls and 1 red ball, I sum these individual cases. Now you can imagine these computations can get vigorous if I have 10 or even 100 trials. Imagine finding all the ways you can arrange 100 items and then calculating the probability of each of them. And then we would have to sum them all. This is where the binomial distribution formula comes in handy, where n is the number of trials, x is the number of items you want, p is the probability of getting x in 1 trial, and q is the probability of not getting x in 1 trial. This exclamation point means factorial, and it tells us to take the number in front of it and multiply it by all the positive integers below. For example, if we are given 4 factorial, then it is equal to 4 times 3 times 2 times 1. If we are given 7 factorial, then we multiply 7 times 6 times 5 times 4 times 3 times 2 times 1. One special factorial that you must know is 0 factorial. 0 factorial is equal to 1, and so is 1 factorial. The second half of this equation represents the multiplication rule for n trials. And the first half of this equation represents all the different ways that we can arrange those n items. Q is the complement of P, so oftentimes the equation is written like this. You may also see this notation for the first term, which is red and choose x. So for this example, we want 2 purple balls and 1 red ball. We can rephrase this sentence as we want 2 purple balls in 3 trials. Then the number of trials is 3, the number of purple balls we want is 2, the probability of picking a purple ball is 25%, and the probability of not getting a purple ball is 75%. This 3 right here represents the 3 combinations that we can make with these 3 balls. So the probability of picking 2 purple balls is 0.141, or 14.1%. Notice how instead of saying we want 2 purple balls in 3 trials, we could also say that we want 1 red ball in 3 trials. They mean the same thing since there are only 2 items that we can choose from. If we do the math, we will get the same result, so don't worry too much about what point of view you should be doing the calculations in. For binomial distribution, it doesn't matter. Well, we know this is binomial since there are 2 possible outcomes. Either you get the question right or you get the question wrong. The probability of getting a question correct is 20%, and the probability of getting a question wrong is 80%. There are 10 questions to guess on, or in other words, 10 trials, and we are trying to get exactly 4 of them correct. This means there is 120 different ways that we can get 4 questions right and 6 questions wrong. By randomly guessing on every question, there's a 5% chance that you will get 4 of the questions correct. The probability of getting less than 5 questions wrong is the same as the probability of getting 4 or 3 or 2 or 1 or 0 questions wrong. Because our events are independent, then we can simplify it to this. And now we just need to sum these. Then the probability of getting less than 5 questions wrong is 0.006. In other words, the probability of guessing randomly and passing an exam would be 0.6%. A fighter has 10 bouts scheduled for the year. He has a win ratio of 22-4. What is the probability that he will win at most 9 bouts this year? If we want to calculate the probability of him winning at most 9 bouts, it would imply using the addition rule. But to make our life easier, let's use the complement. The probability that he will win a fight is 22/26, since he won 22 out of his 26 fights. This will reduce nicely. Now let's calculate the expected value, variance, and standard deviation for binomial distributions. The formulas are really easy. For the mean, it's n times p. For the variance, it's n times p times q. And the standard deviation is always just the square root of the variance. So for our last example, if our fighter were to take 10 fights, we would expect him to win about 8 of them, give or take about a fight. If he takes 26 fights, we would expect him to win 22 of them, give or take about 2 fights.